Hello everyone, welcome to Projects with Gaurang, and today we are going to start the lecture 6 in our machine learning series, which is classification and regression in machine learning problems. So previously we have seen that we have classified the models based on problem statements and we got three categories. These are classification, regression and clustering. If you haven't seen that lecture, I would recommend you to see that lecture because this lecture is somewhat based on that lecture. So now let's see them in a greater detail. Now, what are the key takeaways from this lecture? First, an in-depth explanation of classification and regression problems, implementation of these two problems and understanding the output, then a detailed understanding of entropy in classification problems. This is a very important factor of classification problems. I will explain further in the video, but be very patient and have your complete focus when I'm going to explain this part. And the last key takeaway from this lecture will be an example problem which can be solved by both regression and classification. So we will see that in this video. So let's move on to next part, which is regression problems in machine learning. Formal definition. Formal definition says that it is a problem solving method that uses machine learning algorithms to learn continuous mapping function. So an example of this is predicting the temperature of a place. Like today temperature can be 21.75, tomorrow it can be 24.01 and anything like that. Now the output is continuous. So this problem, the temperature predicting problem becomes a regression problem. Now, how to evaluate these models? See, you made a model, okay, you trained it, training happened. Now you have to check whether this model is predicting the right values or not. For example, let's suppose today temperature is 21.75. If model, let's say, predicted 21.70, it is a quite accurate model, but if it is predicting 2.70, the difference is very much. This prediction makes no sense. This still makes some sense. So that's the thing. We have to check that whether our model has been trained properly or not. Now, there are many functions you can use. First is mean squared error. Then second is root mean squared error or a deviation. And then mean absolute error. All of these three are very popular and you can use any one of them or you can use all of them to check that in different cost functions or different error checking functions how your model is performing. Now some famous examples of regression problems. First is predicting house price, then predicting company sales data based on the previous sales. Like for example, in 2024, how much a sale will happen. That's a question and we can predict by looking at 2023 sales. Obviously, we will include other factors like market condition and all that. So you can include that. You can make model as complex as you want to get a better accuracy. And third example is predicting temperature at any day based on wind speed, humidity, atmospheric pressure and so on. Now, popular algorithms that are used in regression problems. So, linear regression, support vector regression, and regression trees like decision tree, random forest, and there are many other also. So these are popular algorithms that are used in regression problems. So let's move on to next topic, which is classification problems in machine learning. In this, algorithm learn discrete outputs like 0, 1, 2, 3, etc. So these are kind of outputs which algorithm learns. So, it is a type of problem that requires a machine learning algorithm to learn how to assign a class label to input data. This is very important. What is class label? Class label is nothing but what is the category of the particular output. For example, let's suppose that you have divided your temperature scale into the regions like from 0 to 10 degrees Celsius, you will say very cold, very cold. From 10 to 20, you will say good weather and so on. So these become the label. So that's the thing. We train our machine learning algorithm to predict. For example, let's suppose there are three class labels: apple, banana and cherry. First, we have to convert this into a machine readable format. So what we do is we transform that into an array. For example, this shows that there is no class, or the input does not belong to any class. This in training data should not be our case, because this will create ambiguities. So what kind of data you will have? Like A, B and C, apple, banana and cherry, you will map them. For example, if the image is of apple, apple will be 1, banana and cherry will be 0. And that will be for every other training input you will have. Then the model will predict the probabilities of each class. See, our machine learning models are never 100% accurate. They can be 99.99% accurate, but they will never be 100% accurate. So what they do is they give a confidence score, or you can say, okay, I'm 70% sure that this image you are showing me is apple. So that's the thing. So what will happen is that, let's suppose your model is trained. Model, or you can say trained model, is given to you, and you give the image of apple. So you gave an image of apple to it. It processes it and it gives a confidence score that, okay, I'm 90% sure that this is an apple, but it can also be a banana, and or you can say it is not a banana. For that it is 100% sure, and it can be a cherry. There is just a 0.1% or 10% chance. So this is the kind of output we will get: 0.9, 0 and 0.1. Now these probabilities which we wrote in previous slide, let me write them again. These can be from one type of probability distribution function while predicting. This is for predicting. And for training, another probability distribution function can be used. So if the predicted distribution function follows the exact distribution function, for example, let's suppose your input data had a distribution like this, and let me change the pen so that you can see clearly. Let's suppose your output which was predicted also follows the same thing, or you can say same distribution function. Then we say that this is a very accurate model. Now one thing you have to note, that these probability distribution functions are continuous. See, this function is continuous. So it is one of the similarities between classification and regression. And also, if the predicted PDF or predicted probability density function follows the actual probability function, we can also say that the model learns the trends. So let's move on to next topic, which is cost functions for classification problems. So there are two cost functions which are most used. First is categorical cross entropy, and then binary cross entropy. So binary cross entropy is nothing but the special case of categorical cross entropy. It is used when you have multiple classes like 0, 1, 2, 3 and so on. Binary cross entropy when you have only two values for your output. So that's the thing. And this is the formula of categorical cross entropy. In this, what we do is we calculate the entropy, and formula of entropy is minus yi into log of yi. So what this means is, first the prediction and then the log of prediction is multiplied. It is natural log, so if you have studied logarithm, you will know that. So for every prediction it is added and the cross entropy is calculated. Now one question you can ask here is that the probability density functions which we discussed are continuous. PDFs are continuous. That is right. So why we are using categorical cross entropy or binary cross entropy? Why can't we just use the mean absolute error or mean squared error? So the reason is that, see, we want that whenever model predicts the wrong output, it should be penalized more. It should reflect that, okay, you have made a very severe error. So every error should be severe so that our model becomes better at predicting. So that's the thing. See, the reason is that when you use categorical cross entropy or binary cross entropy, more penalty is given to the model, which in turn increases its accuracy. For example, let's take an example of binary cross entropy. Either the output will be 0 or 1. let's suppose for a certain input, the output should be 0 output. But the model predicted the output is 0.8. So what will happen is that we will see this. We will use the formula 1 minus 0. 0 is the actual, that what was the actual probability, or you can say actual output. Then logarithm of 1 minus yi. Yi is the predicted, or let's suppose y dash I. So it will be log of 1 minus 0.8 into 1. Now it will become log of 0.2, and a minus sign is also there. So it will give you a value of 1.64. If you use mean absolute and mean square error, see the values are very less than this. So that's the benefit of using categorical or binary cross entropy, that it gives more penalty. Now, what are the most commonly used evaluation metrics in classification? Accuracy, confusion matrix, F1 score, precision, recall, and there are many more actually you can use. So all of them are used and all of them are preferred equally. In some applications, sometimes F1 score is more preferred over accuracy, and in other applications confusion matrix can be preferred. So it is very, you can say, problem dependent. Now, what are the common examples of classification? First is email spam classification, then classifying dog breeds on physical features, and the third is classifying whether today's weather is hot or cold. Now, what are the algorithms that are used in classification? There are many algorithms, but the three most famous or the three most used are logistic regression, support vector classification, and decision trees. In decision trees, random forests also come. Now let's move on to next topic, which is solving a problem with both classification and regression approaches. So what is the problem? Problem is that you have to predict the steering angle of an autonomous vehicle based on the image data. So what you will be given? You will be given different configurations of the steering wheel. Let's suppose this is a steering wheel and this is 0 degrees. So there will be different images taken at different times, and you have to predict that how much the steering angle is. For example, after some time, this is the steering orientation, or this is the image you get. So still this is the 0 degree line and this is the steering line. You have to predict this angle, this theta. And there are some constraints. So constraint is that, wait a minute. The constraint is that the steering angle can take any value between minus 50 degrees and plus 50 degrees with a precision of plus minus 5 degrees. So what it says is that the steering wheel can move, or the steering can move about 100 degrees total, with 50 degrees in left and 50 degrees in right. And we have taken right as positive and left as negative. And one more thing is that there is a precision of plus minus 5 degrees. What that means is, if you predict that yes, the angle is 10 degrees. Let's suppose you predict this angle is 10 degrees. So at most the angle is in range of 5 and 15. Wait, 5 and 15. So it is between this range. That is the meaning of precision. So how will you solve this problem? First approach is regression approach. This is actually a very simple approach. In this, what you can do is you will map different steering images to different steering angles in a continuous function, which will give you a continuous output. In classification, what you will do, you will make 20 different classes. See, the constraint was at plus minus 5 degrees. So what it means is that I can divide whole given range from minus 50 to plus 50 into the blocks of 5 degrees. So what I will do, I will first start from minus 50 till minus 46 to minus 46. Then from minus 45 to minus 41 and so on till I reach the last class, which is 46 to 50 degrees. So we made 20 classes in this, and then we will predict okay, in which class the steering angle belongs. Now, what are the critical questions you should explore after watching this video? First, what is the difference between classification and regression problems? why we have different cost functions for different problem statements, how are these cost functions decide whether the problem is a classification problem or a regression problem, then why do we use or when do we use this binary cross entropy and when do we use this categorical cross entropy. And one final task for you is, can you find any such problems which can be solved in both ways? Like this, we have solved this problem by both classification and regression. So it's your task to check whether there are any other problems you can find that can be solved in both regression and classification. So that is a task I'm giving to you. So that's all for today. I will meet you in next lecture. Till then, bye.